So let me just share my screen. Okay, so can you guys see my screen now?
Yes, sir.
All right. So before we
Yes,
start,
sir.
okay, very good. Before we start with the module 4 or the number systems, do you guys have a question so far regarding with our discussion yesterday and then with your laboratories yesterday? Questions or any concerns or any clarifications? All right, so I guess none. So if you guys don't have a question, then I guess we can now proceed to the module 4 without a problem. All right, so for the module 4, we'll talk about number systems. We're in under number systems. Okay, wait. So there is a question. Okay. Yeah, you can still pass the assignments. So just let me know. I think you've only missed the quiz number 1 and then the rest are still open. So just message me later on to my canvas, Mr. Ian Angelo, so we can set a new schedule for the activities that you have missed. Okay. All right. So anyway, so I hope I was able to answer your question. Okay, so going back to our module. So again, we'll talk about. All right. Thanks really lang araw na po. Okay, okay. So, just take a rest for now. No, your health is much more important than with your assignments or quizzes that you have missed. So you can always catch up to us as long as the exam or the midterm exam is not yet over. Okay, so you still have 2 weeks. Okay, more or less 2 weeks before the midterms. So just take a rest for now, and yeah, just do that one once you're okay. And what is your valid reason, Mr. Rex Fernandez ba to? Not sure. Mr. Rex, on why you missed the first quiz? Okay. Okay, so it's okay, Miss Karil Fuller. So thank you for attending for our part one since, you already know that later on you're going to have is that correct? You're going to have electricity or interruption of electricity or wala na talaga ngayon. So just join until as long as you can. Okay. And once your phone becomes dead bat or low bat, then that's the time that you can leave our meeting. So anyway, you can just watch the recorded video. So everything is recorded anyway, so it's okay. Hmm. All right. So we'll talk about that one later on, Mr. Rex Fernandez. So message me to my canvas later on, so we can set another schedule for you. Okay. All right. So any other concerns? Okay. Welcome, Mr. Rex. Any other concerns before we continue now our discussion? All right, so I guess there's no more questions. Anyway, so we'll talk about decimals, binary, octal, hexadecimal, and then n-base system. Okay, and then we'll also talk about number conversion and operations, and then sign numbers, and then computer codes. So just to give you guys a brief idea, when I say decimal, it is actually 10 numbers or a base of 10. So if you're going to write that one using a notepad, so in computer, okay, we always start with 0. So decimal is 10 base or a base of 10. So you're going to have 10 characters in here. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So we will not go up to 10 anymore because that is, uh, you know, that already exceeded the base 10. So this one will become base 11. So if you're going to count this one has 10 characters. So up to 9 only since we've started with 0. Okay, so yeah, that's a brief definition of a decimal. So it's base 10. And then for the binary, so this one is super obvious from the word by. Okay, so we're only dealing with two numbers. So this one has a base of 2. So two numbers only, so starting from 0 and then 1. So this one only has a value of 0 and 1. So next one is octal, which from the word octa, okay, 8. So it has a base of 8. So again, starting from 0, 1, 2, 3, 4, 5, 6, 7. So up to 7 only since we have already started with 0. Okay, and then for the hexadecimal, hexadecimal is actually twice of the octal. Okay, this one has a base of 16, so just double that octal. Okay, so starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in here, once you reach 10, this one now is in the form of capital letters, okay, or letters. So in here, 10 is A, 11 is B, uh, 12 is C, 13 is D, 14 is E, and then 15 is F. Okay, so a total of 16 characters. So everything is the same from 0 to 9, the same with decimal. But once you reach this one, 10 up to 15, this one now will become a letter. Okay, it's represented by a letter A, B, C, D, E, F. All right. So anyway, that's the brief overview regarding with those number systems. So what is the reason or why do we need to study about number systems? Why do we need to study those? Anyone who has uh, a guess, okay, or who has an answer on why do we need to study those number systems? Anyone? So you can guess. It's okay if it's wrong. What is the importance of those number systems in computer? Any volunteers? All right. Okay. So to make it short, so as you guys may already know, so as I click letter, let's say any letters here in front of my screen, so our computer doesn't read this one as a letter. Okay. So this one is being read by the computer as a number system or a decimal or a binary or an octal or hexadecimal. So this letter D could be in a form of hexa, could be in octal, could be in binary, or it could be in decimal. But mostly, this one is represented by 8-bit binary. Okay, so let's say D is in decimal. This one is 10, 11, 12, 13. So 13. Okay, so the value of this one in hexadecimal is 13. And if you're going to convert this 13 right here into binary, okay, or 8-bit binary, so it's being represented by 4 plus 8 is 13. 0 and 1. All right. So here's the 8-bit binary representation of this 13 right here. So this is what our computer can understand. Zeros and ones. Okay, so that is the very foundation and how our computer reads the data that we are processing, we are inputting, we are trying to output, and so on and so forth. Okay, so yeah, you're just basically learning on how our computers read the things that we do to our computers. That's being represented by a number system, or to be specific, binary. Okay, wherein of course it has another form which is decimal, octal, and then hexadecimal. But mostly it's only reading 0 and 1, right? So 0 is off and then 1 is on. So later on I will discuss on how did we get this kind of 8-bit binary number. All right. Okay. So the other three is number conversion and operations, sign numbers, and then computer codes. So we will discuss those one by one later. But for now, let's talk about digital circuits. So binary in nature, but several types of representations of numerical data are in use. So for example, binary, 0 and 1, octal, 0 to 7, decimal, 0 to 9, and then hexadecimal is 0 to F. Okay, so those are the unsigned integer numbers. When we say unsigned, uh, by default, it's positive. Okay, so we also have signed integer, wherein, of course, it could be negative or positive. Okay, so if it's negative, then we have another operation for that one. Okay, anyway, again, let's start with the decimal. So like what I mentioned a while ago, this one has a base of 10. Okay, it was derived from the Latin word finger. As you guys can see, we have 10 fingers. Okay, so it uses 10-digit symbols starting from 0 up to 9. Okay, and we have a binary, which is being represented by two numbers only, or a base of 2, or 0 and 1. So again, 0 is off and then 1 is on. Okay, and then let me just talk about the namings, or the things that you guys need to know when it comes to sizes. Okay, so you guys are always hearing about kilobytes, megabytes, gigabytes, terabytes, and so on and so forth. But to be exact, that one started with a bit only. Okay, 1 bit is one character. Okay, and then 4 bits is one nibble. So this one is maybe your first time hearing this term when it comes to size. But yeah, 4 bits is one nibble, and then 8 bits or two nibbles is one byte. Okay, so maybe byte now familiar to you guys. So take note, byte is different from bit. Okay, so this is mostly the misconception. So let's say you have a 25 megabit per second. Okay, so let's say you were connected to Converge. So this is your internet connection speed. But if you're going to, relate this one in download and upload, this is not actually the exact number. You have to divide this one by 8 for you to be able to get the exact uh, download speed. Because in download speed, we are reading megabyte per second. Okay, so take you see this one bit. This is small b, and then capital B is byte. So that is why sometimes, megabyte is, having 3 megabyte or 5 megabyte downloading speed, it's much more better than having 15 or 10 megabit per second. Okay, so the number here doesn't represent, the actual. So sometimes you have to see what is the correct size or the label of that one. So small letter b is different to a capital letter B. So if you're going to convert this 25 megabit per second, so divide it by 8, you'll get 3.125. So this one is equal to 3.125 megabyte per second. Okay, to be exact. Okay, but for 25 megabyte per second, so as it is, this one is has a downloading speed and uploading speed of 25 megabyte per second. Okay, so I don't know if my internet connection is stable right now, but just to give you guys an idea, uh, we were connected to a 25, or we were subscribed to a 25 megabit per second. So supposedly I only have a downloading speed of 25, or let's say ranging from 20 to 25. Okay. All right. So just wait a second. So there you go. So yeah, sometimes it's exceeding the 25, but mostly it's ranging from 20 to 24 to 28, sometimes 30. So yeah, it exceeded the average, which is 25 megabit. So notice this one, we have small b right here. So this one is being read as megabit per second, not megabyte. Okay. So notice we have 30.92. And then let's just say, let me just download a movie. Ano bang pwedeng ma-download? Minari, the father. Anyway, so let's try this one. And I'll download the 1080p, not that one, 1080p Blu-ray na lang. Okay, let me just remove this one. All right, so let's just wait a second. So you will see right here. So as of now, we have 30.92, right? Let me just delete this one. So 30.92 divided by 8. So my downloading speed is 3.86 megabyte per second. So let's see. So let's just wait maybe 2 to 5 minutes just to make this one stable, because it's still, what do you call this one? Bumebelo pa lang, kumbaga. I don't know the correct term in English, but yeah, parang bumebelo pa lang siya. So you guys can see it's increasing. And then later on, this will stabilize, maybe ranging from 3.5 to 3.8. Okay? So this one also depends on, the server where you are downloading that file. So as you guys can see, we have a internet speed of 30.92 megabit, but in here we are only, having 1.6 megabytes, so half of it to be exact. Okay, so I hope I was able to, clear up the things that you guys are wondering about your internet connection. So if you have an internet connection of, let's say, 1 mega bit per second. Say you are in province right now. Say you were subscribed to Globe. Uh, yeah, Globe. So divided by 8, then you're only getting 2 point something kilobyte. Okay, kilobyte per second. So see how slow the downloading speed. 1 divided by 8. 200 kilobyte to be exact. Okay, tama ba? Divided by 8, 0.125. Mas mababa pa pala. So it's 0.125 megabyte. Or if it's in kilobyte, this one is 125 kilobyte per second. Okay. All right. So anyway, there you go. So we now have a stable connection of, stable downloading speed of 3 point something. Okay. Like what I've calculated before, it's 3.8 something. And in here, it's ranging now from 2 to 3, or maybe 3.5. All right. So anyway, so was I able to clear your maybe you're maybe wondering on why we have that kind of downloading speed, but you are subscribed to this kind of speed. Okay, so I hope I was able to solve or answer your questions in mind. Okay, so are we clear so far? Was I able to convince you guys regarding with that one? Hello, hello. Were you guys able to understand what I have just
Sir.
presented?
Yes, sir.
All right.
Yes, sir.
Okay. Kasi kumakain na yung iba, so kaya hindi na nakasagot. Anyway, so again, in here we have another, kind of size which is word, or in here we have 2 bytes which is equal to 1 word. We have 4 bytes which is equal to double word. Okay. Anyway, so here's the representation. So of course, bit is 1 character only, and then 8 bit is equal to 1 byte, and then double word is equal to 16 bit, or what else? Ah, no, sorry. Double word is equal to 32 bit. Okay, because one word is 16 bit. Okay, and then of course one nibble is 4 bit. All right. So again, going back to the conversion from binary to, from decimal to binary. So this is the representation. So 0 is equal to 0000 in binary. 1 in decimal is equal to 0001. Okay, 2 is 0010, and so on and so forth. So how did we get those binary numbers or binary results? All right, so let me just use a paint. All right, so from here we have 0 is equal to 000. I guess this one is quite easy to understand since everything is 0. However, in 1, okay, so it's represented by 0001. So how did we get this one? So in binary, we always start with 4 bit to be exact. It's like this. So let's just say 000 and then 0. Okay. So the rightmost number right here has a value of 1, and then the second has a value of 2, and then the third one has a value of 4. Okay, not 3. Okay, 4, and then the fourth one right here, okay, has a value of 8. So as you guys can see, the pattern is, from the rightmost number, starting from 1, just keep on multiplying that 1 by 2. Okay, so times 2, times 2, and then times 2. So of course, if you have exceeded this one, let's say you have 5 bits, okay, then this one now is 16. If you have another bit, let's say 6 bit, this one now is 32 bit, okay, or 32. And then if you have another bit, let's say you now have a total of 7 bits, so this one now is 64. And then for the last one, okay, let me just transfer this one. Not actually the last one. So let's just say that the 8th bit is 128. So you can have more if you want. Let's say 9 bit. Okay, so just multiply this one by 2, you'll get 256, and so on and so forth. Okay, so that's the values or equivalent values of those uh, bits or numbers. Okay, so as you guys can see right here, 0 is equal to 0 because so it will not activate anything since everything is 0. However, in here you have to activate this one or turn this rightmost number right here into 1 since it is now asking you to have a value of 1. Okay, if you have a value of 2, then just activate. So this one is 1. So if it's asking you to represent this decimal into binary, then just write it something like this. So 0, 0, 1, and then 0. Okay. So as you guys can see right here, you just need to activate 2, and then the rest are deactivated since you don't need their values. Okay. Uh, Question. So, sir, is that how barcodes work as well? Maybe, but I'm not sure. Okay, because a barcode is being represented by lines. But there's a chance since in every barcodes they have numbers. So yeah, there's a possibility. All right. So if it's 3, then all you need to do is activate 2 and 1. Okay. So this one is 0. This one is 0. So you have to activate 2 and then 1. So 2 plus 1 is equal to 3. Okay. And then if you need 4, then just activate 4. Okay. So 0, 1, 0, 0. So this one now is 4. And so on and so forth. So if you need 5, you just need to activate 4 and 1. If you need 6, you need to activate 4 and 2. If you need 7, you need to activate 4 plus 3. 4 plus 2 plus 1. And then if you need 8, then just activate that 8 right there. So 1, 0, 0, 0. For 9, you need to activate 8 and then 1. So 8 plus 1 is 9. For 10, so of course you need to activate 8 and then 2. Okay, so this is 10. And then for 11, so you need to activate 8, 2, and then 1. Okay, if it's 12, then you need to activate 8 and then 4. So 1, 1, 0, 0. If you need 13, then just activate 8, 4, and then 1. Okay, if you need 14, then just activate 8 plus 4 is 12, and then plus 2 is 14. And then this one is 0. Okay, if you need 15, then just activate everything on that 4-bit binary number. Okay, so are we clear so far on how did we convert this one, or how did we get those binary numbers? Hello, were you guys able to follow?
Yes, sir.
How about the others?
Yes, sir.
Okay, good. All right, so if you guys have a question, so feel free to ask me anytime. Okay. All right, so moving on, we also have here octal numbers. So again, octal is or has an 8 numbering system, or has a base of 8, wherein it's ranging from 0 to 7. And then here's their conversion, their equivalence from decimal to octal. Okay, so in here 0 to 7, and then 0 to 7 in octal is the same. However, once you reach 8, 9, and then 10 in decimal, in here it's now being represented by 10, 11, and then 12. All right, so the only advice that I can give to you guys is when we say octal, okay, we're always skipping the 8, 9, and 10. Okay, octal is only or always ranging from 0 to 7. So if we have 0 to 7, we also have 11 to 17, but we don't have 18, 19, 20. So we have 20 to 27, but we don't have 28, 29, 30. Okay, until you reach up to 100. Okay, so that's the pattern. So for the decimal, and then to octal, so decimal, let's say, so we don't have a problem when it comes to decimal. So everything is the same with our number. Sorry. Let's start with 0. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 28, 29, 30. But in octal, so 0 to 7 is the same. 0, 1, 2, 3, 4, 5, 6, 7. But once you reach 8, 9, and 10, so this one is being represented by 10, 11, and then 12. Okay, so once you reach 11 right here, so let me just align this one so it's easier to read. So once you reach 11 right here, this one now is being represented by 0, 8, 10, 11, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, wait. 14 should be plus 3. Alright, so wait, let me just go to my cheat code because we have a summary in here. So 0 to 7 is the same. 10, 11, 12. Okay. Alright, so it's the same. In here, it's 13, 14, 15, 16, and then 17. Okay. Then again, we don't have 18, 19, and 20. So we will jump to 20, if I'm not mistaken. So yeah, 20. So 16 is equal to, 16 right here is now equal to 20. And then 17 is equal to 21, 22, 23, 24, 25, 26, and then 27. And then 24 right here is now equal with 30. 31, 32, 33, 34, 35, 36, and then 37. So up to 31. So if you have more 32, this one now will become 40. And so on and so forth. So that's the pattern when you're going to get the equivalence from decimal to octal or octal to decimal. All right, so we don't always have 8, 9, 10. Okay, we don't have 18, 19, 20. We don't have 28, 29, 28 and 29. We don't have 38 and 39, and so on and so forth. Okay, so yeah, that's the only tip that I can give to you guys for you to be able to understand on why we don't have 8 and 9 in octal. Okay, because as you guys can see, octal is only representing 0 to 7. That's the very main description. So it doesn't exceed to 7. Okay, because when you exceeded 8 or 7, yeah, once exceeded 7, that one is not octal anymore. Okay, that one now has a base of 9. Okay, if you have 8 in there. Okay, so this one is ranging from 0 to 8, while base 8, or this one is the octal that we are talking about. This one is only ranging from 0 to 7. All right, so that's the reason why it only has 0 to 7, but doesn't exceed 8 and 9. All right, so anyway, where are we now? Right here. Okay, so anyway, that's the equivalence when it comes to decimal to octal. Okay, and then we also have here hexadecimal, which is doubled by the octal. So in here, let me just bring this one down. Hexadecimal. Okay, hexadec na lang para pantay. Okay, so in here, 0 to 9 is the same with the decimal. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. 9. But once you reach 10, it is now being represented by letters, which is A. So 10 is A, 11 is B, 12 is C, 13 is T, 14 is E, and then 15 is F. Okay, and then in here we don't have. Actually, we have, but actually there's a different pattern. Okay, so after this one, okay, you have to continue it on 16. We're in 16 in decimal. The equivalent of that one is 10 in hexadecimal. Okay, 10, 10, 11, 12, 13. Let me You just align this one. 12, 13, 14, 15, 16, 17, 18, 19. So once you reach 19, then you now have to continue this one. Okay, so as you guys can see, the pattern is like 1 to 9 right here, and then the continuation after the is after the letter, which is 10 to 7, 10 to 19. Okay, and then once you reach 19, then you have to continue now with the letters. Okay, so letters again, but instead of